This Graham Tech Series 403 Reverse Osmosis Plus Seawater Test Unit is supplying water to Harbour Island along the southwestern coast of Africa.
Raw seawater with SDI levels greater than 5 and a conductivity of 48 millisiemens per centimetre enters the system through the raw feed inlet pipe. The feed then enters the microfiltration unit, and the filtered water flows round and feeds the Series 403 RO desalination unit.
This unit has two spirally wound 15-inch membrane elements in series, incorporated within the high-pressure vessel, and no pre-filtration chambers. The raw feed water is forced through the first flow distributor at pressures ranging from 58 to 64 bar, depending on the feed salinity. Concurrently, raw feed water is channeled through an escape passage alongside the first membrane element. This raw feed mixes with the brine stream from the first membrane element, diluting the concentration levels of this feed water prior to it entering the second flow distributor and membrane element. The permeated water flows through the permeate tube and is instantly available as potable drinking water. No post-treatment is required.
Good health. Because no chemicals at all are used during the desalination process, the rejected brine can be fed straight back into the seawater source from the RO unit.
Membrane backwashing on the micro and ultrafiltration plus units is achieved by automatic closure of the valve in the permeate outlet pipe, which is controlled by the differential pressure meter. If the delta P is higher than 1, the brine outlet valve will close, followed by the permeate outlet valve. Clean filtered water enters through the brine outlet and creates a reverse cross-flow along the membrane element, flushing filtered water through the feed channel. Simultaneously, air is pumped through the permeate tube, entering the permeate spacer envelope, creating a pneumatic cross-flow through the membrane surface into the backwash cross-flow, lifting and dislodging foulants on the membrane surface, which are then washed away in the filtered stream through the feed channel. This stream then reverse flows through the flow distributor and out through the pre-filters. The unique concept of a collapsible spacer in the micro and ultrafiltration plus applications allows particles between 1 to 3 millimeters in size to flow unobstructed through the feed channel. The spacer is flushed out during initial startup protocols. This effectively creates a feed channel of approximately 2 millimeters, which retains its original configuration and non-fouling properties as a result of a combination of factors, which include the continuous delta P, differential pressure, that exists between the customized end caps, the aerated microbubbles and eddy current turbulence generated by the flow distributor, the electromagnetic force field. The conventional solid spacer found in standard micro and ultrafiltration spiral wound membranes has a tendency to allow solids to build up. The 15-inch Graham Tech membranes are wound with the customized collapsible spacer intact. This spacer replaces the conventional feed channel spacer, separating the membrane layer and the permeate spacer envelope. Approximately 46 membrane leaves are wound onto the permeate tube, resulting in the unique 15-inch Graham Tech membrane size. So there you have it. MWD Technologies Breakaway Plus Innovations. all part of its quest for smarter, simpler, cost-effective